we're going to take a basic overview of sequences. First thing, a sequence, it's a collection of objects put in order. Now, what we're going to be dealing with is going to be numbers. Each object is a term. So if I have a sequence that's 2, 3, 4, 5, the 2 would be my first term, the 3 would be my second term, 4 would be my third term, and so on. So each object is a term, and it has a specific position. And then the domain is consecutive integers. If it isn't specified, then it's assumed to start with 1. So that's assuming that this is my first term, this is my second term, my third term. Because our domain wasn't specified that I started with term number 7, then it's assumed to start with 1. Okay, we have two basic types of sequences, infinite and finite. Infinite sequences never end. So if I look at this one here, I wrote down 5, 7, 9, 11. This ellipsis right here, this dot, 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 indicates that it never ends. A finite ends. So because there is no dot, dot, dot here, that tells me that it ends. Another option is that it might go dot, 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 and then let's say 41. Well, that tells me that we're going to do the pattern clear up to 41, but since there's not an ellipsis on the end of the 41, it's still finite. So this one did have an ellipsis in it just because I didn't want to list out everything, but it only goes from 5 to 41. It stops after 41 on this one. Some common notation that we're going to be using a lot is a sub n. This is a subscript, so we just call it a sub n. It represents the nth term. So if I had my sequence 5, 7, 9, 11, and I said, what's a sub 4? That's asking, what's the fourth term? So then I would count over 1, 2, 3, 4. That would be an 11. So the subscript here is just telling you the position that we're looking for. We were looking for the fourth position, so that was our 11. Okay, sometimes we're going to do a sub n plus 1. It represents the term after the nth term. So if a sub n was 4, that means a sub n plus 1 is really the fifth term. It's just saying, well, what's the next term? So in this case, it would be the 13. So assuming that a sub n was 4, a sub n plus 1 is just saying, okay, what comes after that? So what's the fifth term? That would have been my 13. Once in a while, we'll also do a sub n minus 1. And that represents the term before the nth term. So if our nth term was a sub 4, and we're looking for a sub n minus 1, we're really looking for a sub 3, which would have been the 9. So this notation is just telling us different positions based off of the nth term. Okay, there's going to be a couple different things that we can do with our sequences. This first example here says to write the first 5 terms of each sequence. Now, that means I need to let n equal 1, n equal 2, n equal 3, 4, and 5 for each of these cases. So what I'm going to do to get my n equals 1, I'm going to plug in a 1 for my n value. So I would take 4 times 1 is 4, plus 6 is 10. So my first term of this sequence is 10. Then I would go down and do n to be 2. So I would plug a 2 in for the n. 4 times 2 is 8, plus the 6 is 14. So when n is 2, I have a 14. Then I would do the same thing with 3. Gives me 18. Plug a 4 in is 22. And a 5 in gives you 26. So my first 5 terms of this sequence would be 10, 14, 18, 22, 26. If you want to list them out this way, you can, because it's still indicating that this is the first term, the second term, the third term, the fourth term, and the fifth term. Okay, we're going to do the same thing for the next one. So I'm going to plug a 1 in, and when I plug a 1 in, I have the exponent 1 minus 2, which is negative 1. So I have negative 3 raised to the negative 1 power. Now you have to remember your rules for exponents here. When you have a negative exponent, That means we have to cross the line and switch the sign. So it really becomes 1 over negative 3 to the 1, and that's just negative 1/3. Now when I put a 2 in here, 2 minus 2 is 0, so I really have negative 3 raised to the 0. And your rules for exponents, if you have anything raised to the 0 power, it's 1. When I put a 3 in, 3 minus 2 gives me a 1, so I have negative 3 to the first power, which is just negative 3. And when I put my 4 in, 4 minus 2 gives me 2, so I have negative 3 squared, which is a positive 9. And then when I put my 5 in, 5 minus 2 gives me 3, so I have negative 3 raised to the third, which is negative 27. So my first 5 terms for this one are negative 1/3, 1, negative 3, 9, and negative 27. Notice how the sign of this one alternates. It goes negative, positive, negative, positive, negative. Anytime that happens, that's an indication that you have some negative raised to an exponent. And we will talk more about that in a later video. Okay, another thing we're going to have to do is we're going to have to find a rule for a given sequence. Two general ways that we're going to look at right now to do this is you can just analyze the pattern and think in terms of n, and then think about what will get you the next terms, or you can graph to see its shape. We're going to first look at analyzing the pattern. So let's say we had this sequence, 1 over 20, 1 over 30, 1 over 40, 1 over 50. Well, our next term would be 1 over 60, 1 over 70. And if you think about what's happening here, the denominators are being multiples of 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and we could keep going. So now I have to think about it in terms of the position. So my n values, this was 1, 2, 3, 4, 5, and 6. So now I need to think about, well, how can I rewrite this in terms of n? And since I need multiples of 10, that tells me I'm going to be timesing by 10. But if I just do 10 times n, that's not going to work out for me, because my first position should be 20, and if I did 10 times 1, that would only give me 10. So I have to think about, well, I really need to take 10 times 2 to get this. Well, what do I have to do to my n value to turn it into a 2? Well, I have to add 1 to it. So now if I were to plug the 1 in here, I'd do 1 plus 1 is 2, and 10 times 2 gives me a 20. I need to check to see if that works for my next few values, just to make sure my pattern works. So then I would plug in a 2, because that's my nth position. 2 plus 1 is 3, and 10 times 3 is 30. If it works for the 40, I'm going to be done checking. So my position is the third, so I would plug a 3 in here. 3 plus 1 is 4. 10 times 4 is indeed 40. So my pattern, I'm really close to my pattern. It's not 10 times n plus 1. That's the denominator of our fraction. Well, if you look at our numerator stayed the same. So this would be one way to write our pattern. So we could say a to the nth term is equal to this. And that came from just analyzing our pattern and looking at what the sequence was doing. We had multiples of 10, so we knew we had to multiply by 10, but we had to tweak it a little bit because we couldn't just do 10n, we had to do n plus 1. So that's one way you can analyze the patterns. This just takes a lot of practice before you get really the hang of how to do it. Another thing is that it can be helpful to graph it to find the rule. So what we're going to do is we are going to graph an n and a sub n chart. So our n is our x values and our a sub n is our y values. So if I look at my first position, that would be a 6. My second position would be an 8. My third would be 10. And my fourth would be 12. Now you can probably see the pattern here and you could keep going, but let's go ahead and plot these and see what our graph ends up looking like, and see if that will help us figure out what type of a pattern we have. Okay, I've gotten all my points plotted, and as you look at these, you can see that this is actually going to be a nice straight line with a slope of 2. So if I sketch my line in there, that tells me that my pattern for this, my rule to get this sequence, is going to be in the form y equals mx plus b. Now to figure out what that rule is, I need to figure out the m and the b. Well, from looking at my graph, I already have a slope of 2, so I know I'm going to have y equals 2x plus b, and from looking at my graph, I can see my b is exactly at 4. But let's say we didn't see that. Let's say it landed between 2 of the points. Well, you can take any one of your pairs. I'm going to take the 2 and the 8, and you can plug them in. Now the 2 represents our x value, so I'm going to plug that there. The 8 represents our y value. When I solve this out for b, I get 8 is equal to 4 plus b, subtract 4 from each side, and I do get b to be 4. So now when I come back to my equation of my line, instead of a b there, I'm going to put a 4. Now we're really close to having our rule. The only problem is that we have an x and a y here, when really we need an n and an a sub n. So I'm going to replace the y with my a sub n, and I'm going to replace the x with n. And here we have our rule for our pattern, and you can check it too. So 12 was in the 4th position, so let's see if we plug in 4 if we'll get back a 12. So I would have 2 times 4 is 8, 8 plus 4 is indeed 12. So it does work. So this is one way that you can use a graph to see the shape and help you figure out the pattern. So because this one was linear, I knew that it had to be y equals mx plus b for my pattern. Then I could start in using the skills I know about solving for equations of lines and using slopes and intercepts to figure out what my actual rule is. Okay, here's a last one for you. So we're going to graph this one again, find the rule for the sequence, and I'm going to go ahead and make my n in my a sub n chart. And my first position is a 5. My second position is an 8. My third position is 13. My fourth is 20. And my fifth is 29. So we're going to go over here and we're going to plot this on the n and a sub n axis. So go ahead and plot those. Okay, once you get your points plotted here, you can see that it's not linear. So if you sketch your line in here, it looks like it's going to be some form of an exponential one. So we're going to have some type of an exponent in here. Now, most people aren't as familiar with doing exponentials, so we're just going to look at this and try to figure out, well, what type of an exponential is it? So a couple things you can do. You can do kind of a guess and check. So if I use my n term as 1, maybe I'm going to square that and see what it gets me. Well, 1 squared gives me 1. Well, in order to get the 5, I would have to add 4. So let's see if that works for the next pattern. So if I did 2 squared, 2 squared is equal to 4, and if I add 4, that gets me an 8, which is what I needed. I may have gotten lucky here. 3 squared gives me a 9. If I add 4, that gives me a 13. It looks like I do have the pattern. So we got lucky on our first chance. The reason I picked squared is just because it's the smallest one. So let's see, now if I write my pattern here, let's make sure it works for all of them. So 4 squared is 16. What's 16 plus 4 gives me a 20. And then 5 squared is 25, and 25 plus 4 gives me 29. So it does work for me to square it and then add 4 to each one. So now I have to go back and I have to think about each of these values right here was my n. So I took my n squared and I added 4 to it. That would be my pattern.